Hello everybody, welcome back to another video. In this video we're going to talk about this theory response question 1 from 2001. Alright, in this problem we're given two curves. The first curve is y equals tangent x, the second curve is y equals 2 minus x cubed. So in part A it says find the area of R. So basically if I want to find the area of R, so I have to first find this x-intercept, okay, and we know that x-intercept happens when y coordinate is 0, and also this curve y 2 minus x cubed is passing through this x-axis. So basically if I set this equal to 0, we can easily figure out that x value, which is going to be equal to cube root 2. Okay, so basically this x coordinate is cube root 2. Then we need to figure out the x coordinate of this intersection point. Okay, so this is going to be equal to, so the way we can find that x coordinate of that intersection point will be, we're going to set tangent x equal to 2 minus x cubed, because at that point these two curves are intersecting and that point is going to satisfy both of the curves. So basically when I set these two functions equal to each other and use our calculator skills, we're going to end up with x equals 0.902. So I'm going to specifically call this x coordinate as a. Okay, so basically this is a. So now we can get started and find the area of R. So part A, the area of R is going to be equal to, as you may have noticed that I'm gonna divide the entire area R into two sub areas. The first area is going to be in between the 0 and a, and the second area is going to be in between a and the cube root 2. So basically, so let's set up the integrals, definite integrals from 0 to a, and in this part of the area, that area is under curve tangent x. So basically, so not that one. Let me use. So basically, so we're gonna put tangent x right there. So let's put, so the tangent x dx and plus. So let's move on to the second area. The second area, as you can see that right under this curve, which is 2 minus x cubed. So basically it's going to be from a to cube root 2. And also since it is right under this curve, so I'm going to put 2 minus x cubed dx. Okay. So since this problem is calculator allowed problem, so we can use our calculator skills. So when we use our calculator, we're going to end up with this result, 0.72. That's the first answer. Alright, let's move on to the second part. So in part B, we're being asked to find the area S. So let me use a different color. So the area S, as you can see, is right here. So we can find the area of S two ways. The first way is with respect to y, the second way is with respect to x. So finding the area of S with respect to x is way easier than finding the area of S with respect to y. So basically we're going to choose the second way. So all we need this x coordinate, which is a, we found it as you can see. So basically area S is going to in between from 0 to a, which is the x coordinate. And also know that this area S is in between these two curves, 2 minus x cubed, which is the top curve, and then y equals tangent x, which is the bottom curve. So basically we're going to do top minus bottom dx. Okay, so as you can see that the top curve is 2 minus x cubed, integral from 0 to a, and minus the bottom curve is tangent x. Okay, dx. Again, if we use our calculator skills, we're going to end up with this result, 1.161 as the area of S. Alright, so let's move on to the part C. In part C, we're being asked to find the volume, and then you see that it says about the x-axis, which means we're going to find a volume. We're going to find a volume with respect to x, so which means we're going to use the x coordinates. So part C, so the volume, this is we're going to find the volume of the solid S. Alright, and as you may notice that the solid S is in between two curves, y equals tangent x and y equals 2 minus x cubed. And also this solid S is, so the top curve is 2 minus x cubed, the bottom curve is tangent x. So basically, if we apply the washer method, so the pi times from 0 to a, the top curve is 2 minus x cubed, so 2 minus x cubed squared minus tangent x squared and dx. So all of these like pi and squares are coming from the area of circle, because if we apply the washer method and then basically we cut the entire solid into infinitely many thin slices, and each of the thin slices will look like a disc, and we know that the disc is a circular shape. So basically, if we find the area of each infinitely many thin slices and add them up, we get the volume of the solid. That's what we're doing. So basically, again, if we use our calculator skills, this result is going to be equal to 2.652 pi, or if we use the actual value of pi, we're going to end up with this result, 8.332. Alright, so we've solved the first problem. In part A, we tried to find the area of R, and then we divided the entire area into two sub-areas. And in part C, we found the area of S, okay, using this x-coordinate. And in part C, we find the volume of solid S being revolved about the x-axis, okay, and we apply the washer method for that. Alright guys, thanks so much for watching my video. And if you like this video, please subscribe to my channel and share and comment below. Thanks.